guest tonight, so we really want to take advantage of that. So let me first introduce myself and the Data Science Milan community. I'm Gianmario, and I'm the founder of this community. I will give you a very brief introduction, and then we'll start with the technical talk. So Data Science Milan is an independent group that was founded on February 2016. So it's more than 4 years. We are a technical community counting more than 1.7 thousand members. And we meet roughly every month, whether it's physically or online. Like during this emergency period, we meet online events like the one of tonight. I'm not the only organizer. Actually, we are a team. It's a staff of 9 people that help in different tasks of the organization. And right now, we're also looking for other people to join the staff. So if you would be interested on being one of the staff member, we are looking for a social media manager that can help with both posting contents on our social channels as well as creating contents for the website. If you're interested, talk with one of the people of the staff. Just to give you a quick update of the next events, we're gonna have a talk about conversational AI and another one about tools for managing the machine learning lifecycle by TensorWorks. So stay tuned. You can join on the meetup group so that you will receive the invitation to the next event. If you missed one of the previous events, you can go on datasciencemilan.org/past-events. You can find both the links to the YouTube channel with all of the recordings as well as the slides on our SlideShare page. In addition to the recordings, Claudio, who is the blogger of the community, he writes summary articles after every single event. So if you can go on Medium, you can search for Data Science Milan, you can find after a few days after the event, generally no more than 7 days, you generally find the summary article published. Then, if you want to stay up to date with everything going on in the community and everything that we consider to be relevant for our community, you can join our monthly digest. It's a newsletter. We only send you one email once a month, and we put everything that we consider to be relevant within this email. You can find it on digest.datasciencemilan.org. We use Slack, which is our main channel for communication. You can find the members of the community. You can ask questions. During the events, we tend to use the chat in Google Meet. But after the event, if you want to stay in touch with the community, with the member of the community, want to ask a question about any data science topic, you can go on Slack and communicate directly. You need an invitation for that, so you need to go on our website, and then at the bottom of the page, you can find the widget where you can type your email, you receive the invitation. Another thing that we are introducing, it's not yet available, but it's something that we're going to do in the probably September. That is technical coaching. So there's going to be Marco, who was one of the speakers of the previous one of the last 2 events. He was our speaker, and he's going to give this possibility where you can go on Slack, you can ask questions, follow-up questions, you can request more details, or any technical discussion is going to facilitate and coach those debates. So take advantage of that. And of course, for anything you want to know, want to learn about the community, we publish everything on our website. So visit it time to time. If you want to send your proposal because you would like to give a speech, we can just drop us an email, and then we'll organize an event. Wallboard, this is typically where we a place where we put messages that come from the community for the rest of the community. If you don't know, we are part of the Italian Association for Machine Learning. We are one of the community of this network. We made a deal in the last months with one of the, this is just for people that are based in Milan, is if you want to get discounts, it's a 20% discount on all the tax consulting services, just for our members. Plus, we would like to present a few events that are not organized by our community, but we think that are relevant for you. One is a meetup organized by Machine Learning Milan, which is another group, which is and this event is about robots, reinforcement learning robots, and data workspaces, how to deal with the data science project. So we think this is very relevant to you, so we recommend you to join. There's also an international meeting about artificial intelligence, automation, and robotics in Dubai. It's going to be at the end of August, if you're interested. There are a couple of initiatives that are not for international audience. This is only for Italians because it's in Italian. One is this online conference. It's free, so you can register. It's going to be in September, and it's about artificial intelligence and machine learning. It's a lot of topics about artificial intelligence. And then there is also this full stack data school, which is a free, they're offering free classes on data science subjects in Italian. So again, you can go on Google full stack data school, you can read the details. If you want to send us a message because you would like to promote it in the world board, just drop us an email, we'll do that. And for tonight, the agenda is we have Steve, who's the head of behavioral science at Morningstar. He's going to give us this about this topic that is new for us. We never had this topic before. We're very excited to hear from Steve about behavioral science. But before we start with the talk, I need to ask you a favor. We are a community of volunteers, the staff. We don't make money with the events we do. So in exchange to the events that we organize for you, we ask you to help us on spreading the words. So you can find us on any major social platform, Twitter, Facebook, YouTube, LinkedIn. So we ask you to please share pictures, posts mentioning us, such that other people we can reach other people outside our network and the community can. Thank you very much and enjoy the event.
All right. Grazie mille, Gianmario. So as he mentioned, I am Steve Wendel. Hopefully you can see my screen on there now. And yeah, so I'm an applied behavioral scientist, and that is quite different than data science. Now, over the course of my career, I've done a variety of different things. I've recently come out with a book which is about behavioral science, and part of it in talking about the intersection with data science. But in the past, I've seen that there are many different ways that our communities can interact and to learn from each other. So previously, for example, I started a company that did micro-targeting, so machine learning, in this case on political behavior, and ran a research team at a place called Hello Wallet. And what I found is that while we're each in our separate silos, while we each have our separate communities, there's a great deal that I think we can learn and can add to our tool set. Whether we are behavioral scientists, there's a great deal that we can learn from data science, and I think also vice versa. So today I want to speak in particular to some of those intersections. Now, for those of you who aren't familiar with behavioral science, I thought I'd start with just an introduction. What is this? What do we do, right? And then talk about how these two communities are different, and then most importantly, how we can combine them. How lessons from my community, from behavioral science, may be useful in your work. And again, there are many ways also that we are actively learning from the data science community. There is time at the end for questions, but feel free to use the chat window, ask questions throughout. I'll take a pause during each of the sections to see if this makes sense, if there's something else you want to learn about. This is a fascinating field. It is rapidly growing. It is exciting. There's so much going on. And I want to answer the questions that you might have, because again, there's so much material and so many different topics that people might want to speak to. So just one question: Am I coming through okay in terms of the audio? Can you all hear me okay?
I guess we.
Yes.
Okay, great. Just wanted to make sure. Thank you. And thanks for the folks who are typing the message. I can see that now. Cool. Okay, so what is behavioral science? What is this strange thing that we do? Well, you may have seen books like Predictably Irrational or Nudge or Thinking Fast and Slow. And what they show is the different quirks of the mind. What behavioral scientists first and foremost look at is why we do things that just sometimes don't make sense. Why we say, for example, that we want to save for the future. We want to be prepared for retirement. We want to buy a new house, etc. And then we blow all of our money on a new car or on restaurants or something like that. We look at why that happens. And I like to look and see just how this field has grown immensely over the last few years. So you can think of data science has been growing very quickly for about 15, 20 years now. Behavioral science is on a somewhat earlier part of that curve. We started about 10 years ago. But now we have groups all around the world who are trying to understand these quirks of behavior, of how the mind works and how people actually behave in their daily lives. Whether that's big companies like Walmart, Facebook, Amazon, etc., to governments. We see the UK government, the US, the Revenue Service. We see this all around the world. To small nonprofits, to academics. We're seeing a tremendous flowering just over the few years of companies applying this research to understand their people. Now, today I'm going to give a brief introduction, but I also just wanted to just give you a little heads up. I do have a free guide that goes with this talk, which you'll find at Behavioral Technology, that goes in more detail, that talks about all of the techniques I'll be sharing, as well as gives you a bit more of a background. So today is an introduction, but there's lots more that you can learn from this guide. Again, and it's free that you can download. Now, I mentioned there are books like Nudge, Predictably Irrational, all these different groups around the world applying behavioral science. What does it actually mean in practice? I like to use a simple, straightforward example, which sadly is one that is, well, common to many of us. So think about exercise. Now, I know for myself, and I know for many other people, we may have a gym membership. We may have exercise equipment at home. We might have running gear. We might have shoes, whatever it might be. And we really, really intend to go exercise more, right? To use that wonderful exercise equipment at home, to go to the gym, do something that, well, makes us healthier. And yet we don't follow through. It's not because we just like donating money to exercise companies. It's not because we are foolish. It's rather we sincerely believe that by having a gym membership, well, without a pandemic, that we'll actually go to the gym. Or if we have that exercise equipment at home, that we'll actually use it. So we clearly have a motivation because we bought this thing. We bought the equipment. We bought the gym membership. We bought the running shoes, whatever it might be. We clearly had the belief that we would do it, right? So we had the intention. Otherwise, again, we wouldn't spend money on this. But yet we're human, and haven't found any culture anywhere in the world where there isn't this gap between what we want to do and what actually happens. Now, for you personally, it may not be exercise. It may be healthy eating. It may be learning a language. It may be spending more time with your kids. But again and again, across the sweep of human activity, we see this gap in exercise and in other areas between what we want to do and what we actually do, between our intentions and our actions. And as behavioral scientists, we study why that happens, why people say they want to do something and do something else. And then most importantly, we study what we can do about it. And when we look at why this happens, of course, in our own behavior, we have lots of reasons. It might be, I was busy. I was doing something else. Or, I just don't know how to use that stuff. I think I'll look like a fool. Our emotions come into play. Our sense of, we procrastinate, etc. And as behavioral scientists, we have specific names for these reasons, or really what underlies it. What's happening in the mind that causes this gap, that stops us from taking action when we want to? So one of these examples is descriptive norms. So maybe you're not going to the gym or not exercising because when you look around at your friends, they're not doing it either. Or again, maybe it's healthy eating, or maybe it's learning a language, or whatever the behavior might be. And so because so often we are social creatures, and even though we ourselves may know the value of exercise or healthy eating, etc., when we see other people not doing it, we're like, I don't need to do it either. And it works in reverse as well, right? When we see other people over drinking, when we see other people smoking, when we see other people doing something risky, it feels more natural for us to do it too, even if deep in our hearts we know that's not the right thing for us to do. There are other biases that can come into play here. So with exercise, a particularly powerful one is what we call temporal myopia, or present bias. We are extraordinarily focused on the current moment and the benefits and the costs. So if I'm sitting on a couch and I'm watching Netflix, right, I think, oh yeah, okay, I could exercise. That's going to help me in what, like 20 years? But right now I got this great show. I want to watch this show. That's our temporal myopia. That's a focus on the near-term benefit rather than the long-term, or for that matter, the near-term cost rather than the long-term cost. It may, for some people, it may be actually quite the reverse. And we may think, oh yeah, okay, I know other people need to exercise. Other people need to eat healthy. But look, I'm actually fine. I get up in the morning, I feel pretty good. Because so often we overestimate our own ability and we don't see, well, how much we might struggle, how much that gut is growing. That would be me personally. How much we might have other challenges. And so these biases can affect us in very different ways. And behavioral science helps us understand where one factor may come into play versus another. Now, the challenge is, when we think about exercise, when we think about something in our lives, it's so easy to recognize that, oh yeah, okay, I was just busy. I'm not a terrible person. It's not that I don't want to go to the gym. It's just something came up. And so we make these excuses for ourselves, and we recognize this at work. But we don't do that for our users. We say, I have built this awesome product. Why aren't my users using it? Well, probably because they're just as human as you are. They're just as likely to procrastinate. They're just as likely to go on their emotions rather than on the wonderful value proposition of your product. And so behavioral science helps us not only for our own lives, but to help us understand the behavior of our users, what they're doing, where they struggle, and where they may look you straight in the eye and say, I think your product is awesome, and then never, ever use it. Why that happens. And so if you take a step back from this, from the literature and from this example of exercise, behavioral science is really three things. First, it's an understanding of this gap. It's an understanding of how people actually behave in their daily lives that most of our models just aren't very good at predicting, right? It's a deeper understanding of the psychological barriers that stop people from taking action, or sometimes make them take bad actions like smoking or over drinking. Second, it's a set of tools to help people do better. We have interventions, we have techniques that can change this dynamic and help people exercise, help people not smoke, etc. And then finally, we are data people at our core. And we believe in the rigorous testing of our results. And we use a particular method of experimental testing, A/B testing, to do that, which I'll talk about. Now, at least in my community, people often confuse data science with behavioral science. Not among behavioral scientists, but people asking, like, how are these different? And so I think you've already gotten a general sense of that. I want to give you more specifically. We're trying to do something that's different fundamentally. And that you can summarize as this. Data science is broad and powerful, looking at how we can understand and to predict. Sometimes it's human behavior, sometimes it's other systems, etc. Behavioral science is narrow and precise. We are trying to do one thing and do it extraordinarily well, which is to change behavior. We only succeed, we only know that we're working when we help that person exercise. Not when we predict they're going to exercise or not, but when we actually help them do it more often than they would otherwise. And that's a different standard. From this goal of understanding and prediction versus behavior change, there are consequences in the statistics we use, there are consequences in the approach we use, there are consequences in kind of what it means for our daily work as data science versus behavioral science communities. So if you think, for example, let's say you're working on an app that helps people exercise, right? And what would be, and you've got a detailed amount of information about people's exercise, their what they do in their daily lives, etc. Some common data science questions that you might ask would be, what are the risk factors of, for example, heart disease and somebody who needs to exercise more, or obesity for that matter? Or from a commercial side, how can we predict the likelihood of who will buy our app? Make sure we market to them, make sure we reach out to them, okay? Now, a behavioral science question, and there is, of course, overlap between these, but a more stereotypical behavioral science question would be, okay, we know that some people have this risk for heart disease or obesity, etc. How do we help them exercise more than they would have otherwise? Not how do we target people, but rather how do we change fundamentally what they do? How do we change people rather than identify people? And then second, from a commercial angle, how do we increase that likelihood of buying? How do we speak to that emotional reaction? How do we speak to that, to the biases of the individual to help them connect with this product that they might need? I hope that makes sense. Again, you're feel free to ask questions. Oh, I forgot to take a break actually between the two. My mistake. Let me just go click. Thank you, Jean Mario, for sending out the link to the guide. If you do have questions about behavioral science and this kind of distinction that I'm making, please feel free to ask questions as we go along. Everyone still hear me okay? All right.
Yes.
I think that is a stunned silence. Yes. All right. So different types of questions come from this core goal of prediction and understanding versus changing. Now, of course, some data scientists are also involved in trying to change that behavior based on their analyses. This is kind of the core focus of our two different fields. Now, from this, there are different statistical techniques that we use as well. Oops, just saw a chat question. Grab that. Yeah, is behavioral scientists what we'd call prescriptive analytics in data science? Not exactly. And let me describe what that is here with the stats. So in a data science world, often you have a tremendous amount of data, and you're looking for hidden patterns. You're looking for how can we best understand who will take this action, how this system might work, etc. What can the data tell us from, and you often need quite a lot of information, detailed information. Behavioral science is fundamentally, we don't actually need that much data, right? It's wonderful when we do, when we apply machine learning techniques as well. But the core of our success is something different. We're looking for an obvious effect. We're looking for example, in an A/B test or a randomized control trial. We only really need one thing. Did the group exercise or not, right? And we compare two randomly selected groups to see that effect. And so in our world, our primary statistical technique is a t-test, for example, or a test of proportions to see whether two randomly selected groups have different outcomes. Now, as I mentioned, there's a great deal that behavioral science can learn from data science. And so often we actually combine machine learning techniques with this experimental evidence. But if you think of kind of the core of the field, these are different goals. And so when you think of a prescriptive analysis, is generally based on the current characteristics of a person and of an environment. And that gets us part of the way to behavior change. It's tremendously powerful. We're trying to dig a little bit deeper and change that environment, fundamentally change something about the environment in which people work so that they act differently and hopefully are different, right? Their behavior changes because of a change within and a change of their environment. And so you can think of it as a step further than what is generally a prescriptive analysis, okay? And now I wanted to get to the meat of it, which is, okay, great. We see what this is. We see how these two communities are focusing on somewhat different things. what does this actually mean for your job and for your work? And how might you be able to draw from behavioral science in your work in data science? And again, there are many ways that we can learn from you, but I'm not focusing as much on that today. Okay. And so, sorry, another question before I dive into that, and I'll also take a drink. Right, so how do you select a good sample for A/B testing? Excellent. You may have an obvious effect, which is a fluke. Yes, and so we need that, we really need that outcome variable because we're using a different statistical model, okay? And ours is, often when one is doing a causal analysis in a statistical model, whether you're doing a structural equation or you're doing some type of regression model, you require lots of variables to control, for example, for it being a temporal fluke, right? That is just that particular, at that moment, something strange happened. Or maybe it was just this particular population, or maybe there were more men than women in a group, etc. Okay, and so the statistical controls that you build into an econometric model, into a statistical model, right, are built into the process of designing an experiment. And so effectively, if you design a randomized control trial and A/B test correctly, and I know that many of them out there aren't, but as from a behavioral scientist, when you design these correctly, then you are effectively controlling for that fluke. You're controlling for strange differences between the populations. You're controlling for other causes that might have caused that obvious effect. And in a proper randomized control trial, you know, and the best standard we have in science, in the history of science, that what you did, your intervention, is what had that effect. And I'm happy to talk more about the statistical basis for that if you'd like. But it fundamentally comes down to this idea of controlling for the fluke, controlling for those other explanations. I hope, Mark, that answers your question, and feel free to ask additional ones as they come in. Okay, but that's why our statistical methods are often different, is because in the structure of how we set up a test takes care of most of the statistical complexities, right? A randomized control trial takes care of that for you. Okay, and when you're doing data science, you generally don't have the luxury of running a randomized control trial. Instead, you're dealing with the observational data, and so you have to build in these statistical controls, instrumental variables, etc., to get there. Okay, so I hope that was useful. When we think of how do you apply this, right? One of them, of course, is randomized control trials. But let's look at how you can use your existing data differently, thinking about that data in a different way. And let me use the example of descriptive norms. Okay, so you're looking at product uptake, for example, whether it be your own product or whether it be a larger change in the overall environment, and you see, wow, there are lots of people now doing this. What happened? Did its value proposition change? Was it a good marketing campaign? Behavioral science helps you ask a different set of questions of what might be driving a change. For example, maybe people are now really excited about TikTok, not because TikTok is fundamentally a better platform, but simply because they see other people using it, right? Herding behavior, or descriptive norm, we look for that social signal as well as the quality of it, etc. Right? And these are, of course, questions that a data scientist can look at as well. We have a framework that helps us think about these range of questions you might want to look at in your data, right? And it helps you combine that analysis with the observational data you might already have. And more generally, we should ask if we see, for example, in product uptake, let's say somebody that people aren't taking up a new product. Is that because fundamentally they don't like it? Or is it because of a gap between intention and action, and a slightly different marketing campaign, a slightly different approach, or a way of presenting this product may in fact bridge that gap? And we don't have to change the fundamental value proposition. We don't have to change anything core about it. It's really understanding that gap between intention and action. And so we think about that gap between intention and action as a set of stages in the mind that a person has to go through in order for them to take action. And this is kind of a checklist. So when I'm doing a data analysis, when I'm looking at human behavior, I think through at each step these 6 things. Okay. First of all, is there a cue? Where is somebody's attention? What is the data signal that I can find about their attention? Because if they're not paying attention to the action, Doesn't matter. Doesn't matter the value proposition, doesn't matter how awesome it is, doesn't matter if you'll help them. Attention is the first barrier. And so I look for the data footprint of attention. Second is the reaction, the emotion that a person feels. Again, putting aside value proposition. What are they feeling in that moment? What signals do I get of that? Third is the evaluation, the conscious cost-benefit analysis. What we find in behavioral science is that people aren't computers. They don't predict as our models would expect. They don't see the benefits in a clear way. They don't see the costs in a clear way. Rather, there's a mathematical warp that occurs in their minds, a warping of the calculation of what's good and bad. And we can understand that and see where things might be going wrong for a person. We look at the ability, right? Do they feel confident in it? Do they feel that they will succeed? We look at procrastination, that's timing. And we look at their prior experience. So their history and how that can overwhelm the benefit of a product, right? This is a checklist of when you're looking at behavioral data, these are the things you look for: attention, reaction or emotion, the warping of one's cost-benefit analysis, etc. And to give an example of this, let me give an example from Uber. So Uber was working on the waiting experience. So people would, they'd rolled out Uber Pool, and the behavioral science team, which was actually embedded as part of their data science team, was looking at this problem of people waiting for a ride. People were getting very frustrated. Like, oh God, I gotta know, wait another 5 minutes. They're going picking up this person. This is a pooled ride where there are multiple people. And now their data science team could spend, and Uber did, spend a tremendous amount of time and effort working on the algorithm to make it more efficient, so people didn't have to wait as long. But fundamentally, the car's over there, you gotta wait, right? The algorithm can only get so good. And so the behavioral science team tried something very, very different, which was, rather than trying to optimize the algorithm, change the experience of waiting for the person. And what they used was a technique called the labor illusion, which is to show people what's going on during that wait. So they're not just frustrated and saying, okay, where's my car? Where's my car? What's going on? What's going on? They rather said, okay, this is where it is. This is what's going on. They gave frequent updates that showed what was happening behind the scenes so that people would be less frustrated. So the same outcome, happier clients, less frustrated, with a change that takes, I don't know, a designer and an engineer, right? A few days to put in, just show what what's going on behind the scenes, versus a tremendous effort to increase the effectiveness of this algorithm, understanding that you can only get it so far. Behavioral science often finds simple, cost-effective, very cheap ways of solving a problem that you can combine with an understanding of the underlying data and the understanding behavior, where a purely data science approach, it just has its limits. And so that's why we look at the combination of the two. There's some factors that only data science can solve, and some that only behavioral science can solve. And so we look at how we can use both, like Uber did with their combined team of data science and behavioral science. Here's an example from Hal Hirschfield at UCLA and Dan Goldstein at Microsoft, which is saving for the future. Now, in many countries, the US and I believe Italy as well, there's a significant problem of people not saving enough for the future, right? And so one approach would be increase interest rates, advertise how important saving is, etc., right? And that's very costly. What Hal and Dan and others found is that you can show them what they look like when they're old, and that actually shocks people into saying, oh, wow, I'm really going to need money when I'm older, and they save more. And so we look at, you analyze the behavior of individuals, you look and see what is their contribution, who's struggling with this. That's a data science task, right? You predict who might have a problem, right? And then take a behavioral science, you combine that and say, okay, here's a quick, clever way to help them in that moment. That isn't a large ad campaign, that isn't a changing of incentives, etc., right? That's a combination of these two approaches. In the exercise arena, this is a fun one from Katie Milkman at Penn, where they wanted to help people exercise. And so they combined something that people really wanted to do, but they procrastinated, which was exercising, with something they really wanted to do right now, which was listen to this great audiobook that had just come out that was very exciting. And so they locked the audiobook in the gym where people could only access it there, right? And so they analyzed the behavior of individuals. They found that this was a problem, and they used behavioral science. They combined a behavioral science solution to help people exercise more. It's very effective. It's fun. And so that's the first way in which we can help people combine data science with behavioral science, is by looking at your existing data differently, from a different lens of what's going on psychologically and what might be some changes we can make to help them. Now, we also want to look for additional data, right? And I'll use the example of descriptive norms again, where you might have a sea of information about people's behavior, right? Let's say it's for smoking or for overeating or for drinking, right? Behavioral science helps you say, okay, let's aggregate what we've got. Let's process it into a social signal, for example. Do we know the reference group? Do we know, for example, if I'm looking at whether other people are exercising or not, who am I comparing myself to? That's a different data point that we might not already be gathering, and it's one we can go look for. We can look for what relationships people have with each other, right? Again, this is something that a data scientist might generally have access to, but this helps you prioritize that data ingestion and the analysis of that particular data point. And as I mentioned in the create funnel, we look at the prior level experience, because descriptive norms, herding behavior, is particularly prevalent when somebody is new to something. We don't see herding behavior as much when somebody has taken an action many times. When it's familiar to people, herding behavior isn't so much of an issue. We also look for a particular data about what we call micro behaviors. What are the small sequences of actions that people take, right? Now, in an application, of course, that's page views, but or particular clicks, particular parts read. But in daily life, it's a bit more complicated. So let's use the example of exercise. So the type of data that we would look for in whether somebody exercises, and let's say uses this app that your company has developed to help people exercise more, might be, okay, what are all the things they have to do? They have to have received the email about the app. They have to have opened it, downloaded it. They have to have turned on notifications. They have to have gotten a notification at a time when they might exercise. They have to pay attention to it. They have to have the gym clothes ready at that time. They have to get their gym clothes. They have to know where the gym is. There are a tremendous number of small steps that are required. That's what we call micro behavior. And that's the data we look for. Because what we find is that people may really want to do something in general, but it's in the specific moment. It's the fact that their phone was somewhere else and they didn't see the notification, or they got the notification, but they were watching Netflix and they were busy doing something else in that moment. It is in the moment that human behavior is decided. It's not in the general value proposition. It's not in a general statement about whether they want to exercise or not. It's rather those tiny, tiny steps that can either enable somebody to act or not. And as we're analyzing behavioral data, it's a particular sensitivity to the small things that happen in a person's life. And from that, understanding what we can do about it. Now, what we can do about it is using that create funnel, gathering data about, so I mentioned before, the things we look for are attention, the emotion, etc. And that's, if we don't have that data, of course we need it. So what do we know about the emotional reaction? What do we need about evaluation? What do we know about the person's procrastination, their sense of urgency? And is this a problem? And so we actually do that at each step. Each one of those micro behaviors, we look for these 6 signals in the data. Okay? And so that creates kind of a time series, detailed time series for the individual with 6 data points per time period when you can get it, right? Now, you can't always do that, but this is the type of stuff you look for to be able to analyze human behavior in detail, okay? And where possible, you look for, hey, do you have an experiment? Because that's what gives you the clearest signal science has to offer about an effect, about a causal effect, is a randomized control trial, or the simplified version is an A/B test, okay? We also look and say, okay, if it's of interest to you, you can combine these in a way that you move from data analysis to behavior change. I know that many data scientists work in an insights capacity, which is analyzing a system, analyzing what's going on, and then providing a report to a decision maker who then looks at that and says, okay, what are we going to do from this, right? There are often recommendations as part of that, but it's very difficult to say, okay, is this going to affect change? By combining in behavioral science, we can use these techniques to actually measure that impact and say, okay, we're not giving just an analysis, we're giving a statement about what our effect is, our ROI from this at a causal level, right? And this is tremendously powerful, right? It puts you more in that decision maker role, in addition to being an analyst, in addition to being someone who's providing that insight for a company. And so, for example, if you want to stop hurting behavior, coming back to that example, there are lots of techniques. You change the reference group. You make it something more familiar to a person where they look at a different history of their own behaviors. They're not uncertain, etc. And there are tremendous number of these techniques. In the workbook that I mentioned, you'll find a detailed guide that talks about for a given problem. If the problem is attention, here's some things you can do. If the problem is the emotion, here's some things you can do, etc. Again, that's all in the guide that I mentioned before. You can find on the site that Jean-Mario sent over. And then finally, there's one more that's a little different, which is we can help use behavioral science to understand our own behavior, what we're doing, where we struggle, right? And I mean this in two different ways. One is, hey, you really want to study a new technique and you keep putting it off, right? Or you really want to prepare for this conference, and well, the deadline's out there, and you get involved in something else, and there's a gap between your intention, your sincere desire to prepare for this, etc., and what actually happens. So we talk about applying behavioral science to ourselves, to our own behavioral obstacles, to what we struggle with, so we can be more effective in our careers and more effective at helping others. And it also comes down to what's known as algorithmic bias. I'm sure many of you have come across this, especially it's a hot topic in the AI world, where we are human beings and the algorithms we develop are representation of our humanity. So there's a very highly publicized example of an algorithm that Amazon developed for recruiting. And it's systematically biased against women. And sadly, there are many other examples of algorithms that are, for example, facial recognition that is terrible at recognizing African-American or people of color, right? That is very good for European Americans like myself, but not for other folks. And the challenge there is that we have an intention-action gap. We don't want to create biased algorithms, right? But instead, when and this depends on the particular community, if it's a primarily male AI group, which some are and some aren't, but if it's a primarily male AI group, this is just a blind spot. It's something that people don't think about because they're surrounded by and they're testing it against their peers, they're testing it against each other. They say, yeah, this thing works great. Behavioral science can help us understand when that happens, why it happens, and to know that it's not bad data scientists or bad AI researchers. It's rather this gap between people who want to do good and, well, they just don't think about this. They have a blind spot. In this case, it's usually a confirmation bias or an overconfidence bias in how we develop the algorithms. And so this particular one is from a great talk by Gunna, which talks about the use of behavioral science to improve diversity and it just resolve some of these algorithmic bias problems. And so if we take a step back from what I've been from the conversation today, it's this. If we can summarize and look at what we've discussed, is that behavioral science studies the strange things that people do, especially the gap between their intentions and their actions. How good, well-meaning people can create algorithms that are biased, can want to go exercise but don't, and how companies all around the world are now studying these quirks, studying these gaps and what it means for their business. It is a tremendous growth field. There's a great deal of excitement in this new field. And it's an area that we can combine lessons from behavioral science and data science, because we often ask different sets of questions and we use different methods for that, right? From prediction and understanding to, in particular, specific behavior change, right? And there are, thankfully, tools out there already that can help you with this. A checklist, for example, of what types of data to look for and which ways to analyze the data in terms of human attention, human emotion, evaluation, etc. We find that by combining these, by understanding a particular problem, we can sometimes find cheaper, faster solutions than one might otherwise have, right? By using just the tools from one community alone. And again, in behavioral science, we have a tremendous number of tools that might be useful for your work, especially if you're looking to cross that bridge directly into behavior change work. And we have a certain responsibility to apply behavioral science to ourselves to see where we struggle, where good, well-meaning people may fall prey to confirmation bias just like everybody else, and how we can overcome that. Everything I've talked about today is available in the guide, Designing for Behavior Change. The book itself, the second edition, just came out about a month ago, and this is a free guide that helps you understand these issues and apply some of these techniques in your own work that you can find. And that's it. I hope that was useful for people. I'm happy to answer any other questions you might have. Yeah. Okay. Oops. Let me scroll down here. There we go. What are some good sources to collect useful information about studying behaviors? So you don't want to run research studies on each person. Yes, of course. So, I mean, it really depends on the particular problem you're trying to solve. For financial behavior, for example, there are long-running panel studies both in the US and I believe in Italy as well that look at this. And so there's social science data sets that we can gather and use to understand in this way, right? If you're looking at exercise behavior, that's a different data set. In the US, it's there's a health study, long-running health study. So it really is going to depend on the particular subject area. And then if you're dealing with digital products, it's detailed page view, detailed screen action. Eye tracking we find is not quite as useful. I can add some, but really, what are the things people do? Have we instrumented the tool properly? Are we studying it well? I really love to use the tool Heap because it allows us to analyze that detailed behavioral data, even if there's a question we hadn't thought of before. So it gathers everything, and then you can specify what you want to look at afterwards, which is really cool. So hope that was useful. Other questions? Thank you. That's very kind. Grazie mille, Mattia. Okay. Other questions people may have? Are we good? I know this is a very different field. I know for some people this might be the first introduction to behavioral science. Thank you. Okay. And feel free to reach out to me as well. There's a link at, oh great. There's a link on behavioraltechnology.co where not only can you get the workbook, you can also reach out to me. And my email is just steve@behavioraltechnology.co. So I hope that was useful for everybody. I see some folks dropping off now. So I think we will call it a day. John Mario, is that good?
Yeah. Very inspiring. I really look forward to read your the guide, the handbook, Designing for Behavior Change. I want to ask you, would you share these slides with us so we can publish on our channel?
Oh yeah, happy to.
Great, thank you very much.
Sure. There was a question about ad tech. Yeah, there is a tremendous amount of noise out there. That's quite true. See, I work a lot more just in core marketing technology. So looking at email response and testing, website, app behavior, etc. Happy to supply those if you want to reach out to me. That's of interest. I don't do as much specifically in ad tech, but if any of the general MarTech stuff is useful, I'm happy to send those over to you. Just send me an email. Sorry, Jean Mario, I wanted to answer that question.
Sure.
Great. So I think we're good. Thank you, everyone.
Thank you, Steve.
As usual.
Yeah, just share the slides. You can send to me via email.
That I will.
Publish it.
You bet. You bet. I'll put them up on SlideShare so y'all can see them. No problem.
Thank you very much.
Great. Thank you all.
Bye.
Bye.